Hello students, welcome back to Akshar IT Foundation classes. I am your chemistry faculty S. Mohan. Students, we are doing this 6th class, right? Yeah, in the 6th class we are doing the separation techniques. This is the last chapter and today is the last topic of this IIT Foundation class. Okay. So students, here in this chapter we are studying about the separation of mixtures. If two or more things mixed together, then how can we separate? So in the chemistry we use different techniques to separate the mixtures, right? In that we are discussing about the solid, first one, second one, solid liquid, second one, and third one. Today we are going to discuss about the liquid in liquid. What we are going to discuss today? Yeah, liquid in liquid. So methods of separation of liquid in liquid mixtures we are going to separate. Clear? Okay. So students, here what we are going to do here is, so if two liquids are mixed with each other, how can we separate? Okay. So there are mainly three methods of the students to separate. One is by using separating funnel. What is that? By using separating funnel. Okay. This is the first one. Second one is distillation. This is normal distillation. And third one is a fractional distillation. Okay. So there are three methods which we are going to learn today, how to separate the liquid mixture. Means if two liquids are mixed with each other, then how can we separate? So the three methods are there. First one is what? Separating funnel, by using separating funnel. Second one is what? Distillation. And third one, fractional distillation, right? So here you see students, here first one we see, this is separating funnel. Okay. So if you see here, this is a separating funnel. So where this method we use? This method, this separating funnel, we use to separate the two liquids with different densities or immiscible. Okay. Immiscible means what? If two liquids we are taking, but these two liquids will not mix with each other. Imagine that they don't mix with each other. Students, you know that, for example, if you take the oil and water, okay, does they mix with each other? No. So once you try, so take one small beaker and in that pour some water and then pour some liquid. You will observe that water and oil do not mix with each other, right? So here also in such liquids, if they are there, if two liquids which are immiscible means what? Which do not mix with each other. So here for example you see here oil and water. Okay, the two liquids we are taking, one is oil, other one is water, oil and water, right? So now if we mix, for example, you think the oil and water is mixed, means or dropped or in only one beaker in somewhere. Okay, these both are mixed. Okay, now how can we separate? So here students, this we can separate by using the separating funnel. So students, here you can see this is the separating funnel. Can you see here? This is the separating funnel. Okay, this is the separating funnel, right? And here there is a small, okay, like what you say, like tap. Okay, this is like tap is here. And now in this funnel we are going to take the water and oil. Okay, we are going to take oil and water. So first pour the oil and then you take the water. Water also you can take, pour these both together and now shake well. Okay, they shake well and fix this separating funnel to the stand. Now you can fix this to the stand and wait for some time undisturbing it. Without disturbing it, wait for some time. So during this time what happens? The water density is more comparatively oil. The density of water is more comparatively oil. So then what happens? This more dense water, the water comes down. Okay, what happens? The water comes down and oil will be moving upwards. Okay, oil will be moving upwards. If you wait for some time, you will observe that all the water will be coming here. So you can see here, this all water will be coming down. So here water will be coming here and so this is the oil. Now here it is the oil, right? So water will be coming down and oil will be moving up, right? So now this type of scene you can see in that separating funnel. Okay, when this is achieved, means when you can see clearly the separation of oil and water, then what you do, you take one beaker or conical flask here. So this is a conical flask, okay. So in this conical flask you place here, okay, below this one, and now slowly open this tap. Okay, so open this tap. So then what happens when you open the tap? Now this water will be falling down. See now, the water is falling down. So water will be falling down and oil will be remains, okay, here at the top of the water. Okay, so slowly water is coming down. So when the water completes, when the water comes here, when it completes the water, then immediately, okay, off this one, okay, close the tap, switch off the tap, and now you take out this beaker separately. Now this beaker consists of water and this funnel consists of oil. So like this we can separate the oil and water. So for which so this separating funnel where we use for the two immiscible liquids. Two immiscible means water which do not mix with each other, immiscible liquids, or we can also use for the solutions which are differs in their densities, Remember, this is very important. Okay. So once you see in your page number 83 in the material, methods of separating liquid mixtures. First one is what? By using the separating funnel. So see here, this method is used to separate the components of a liquid plus liquid mixture in which both the components are immiscible. This is very important, and their densities are different. So different densities are different. So in such case we can use this method. Is this clear? So what we can separate by using this one? So we can separate the petrol and water. We can separate the vegetable oil and water, kerosene and water, chloroform and water, mercury and water, benzene, like this. So many things we can separate whose densities are different and which are immiscible. Is this clear? So that is about the separating funnel. So now let's go to the next one, second method. So this is separating funnel. For where we use this separating funnel? Where the two liquids are immiscible. Okay. So here this is the say here. See here the lighter petrol. Can you see here? Petrol and water if you take. So petrol moves up. See here, petrol and water. So then what happens? The petrol moves up and water comes down. So when they clear, separation takes place, at that time you can separate them. Clear? Okay. So this is about this one. Now, so in this method what we can use? So we can separate the vegetable oil and water, kerosene and water, chloroform and water, mercury and water, benzene and water. So these things you have to remember. Okay, vegetable oil and water, kerosene and water, chloroform and water, mercury and water, benzene and water. All these things we can separate by using this separating funnel method. Clear? Chalo. Now the next one is a fractional distillation. This is very important. What is fractional distillation? Already we discussed yesterday in the distillation method, right? So distillation method also can be used here. Distillation and fractional distillation both are same with a small differences there. Generally distillation we can use for the two solutions, for the mixture of two liquids where the boiling point difference, okay, the difference in the boiling point of two liquids is greater than 25 to 30. Means what? For example, if you take the water, okay, so water boiling point is 100 degrees, you know that, and then you can take the acetone, okay, acetone is approximately 56 degrees I think, so 56 degrees Celsius is the boiling point of acetone. For example, if you take the water and acetone, so water is 100 degrees boiling point, acetone is 56 degrees Celsius, okay. If you mix these both, this both will be mixed with each other, acetone and water, these two liquids will be mixed with each other, okay. Now if you want to separate, so in this case we can use the distillation. Okay, so distillation difference, where we use the distillation if the difference in the boiling points is greater than 25 or 30 degrees. So here acetone is 56 degrees and water is 100 degrees. So difference is how much? Almost 44 degrees, right? So now this 44 degrees is greater than 30 degrees. Okay, in such case we can separate easily by using the distillation. So distillation means what? Very simple. In the last class I already explained you, I think. So here what we do is so here what we do in the distillation method, so this consists of one round bottom flask. Okay, this consists of what? Let you think, one round bottom flask, and here it is, okay, this is the neck of the flask, and here we take the mixture of two liquids. So these are the mixture of two liquids, and here for example acetone and water we are taking. What we are taking? The mixture of acetone, okay, acetone and water, right? So acetone is, what is the boiling point? I say 56 degrees approximately, and water is 100 degrees. So difference is how much? Difference is 44 degrees Celsius, right? Now in this what we do? Now, okay, so before that what we do is we fix with this cork and we insert one thermometer here. What we insert here? One thermometer to see the temperature. This is a thermometer. And then what we do? We take one delivery tube. So this is a delivery tube, and in this delivery tube, okay, we put one beaker like this. For example, roughly I am drawing here one beaker. Okay. So here even condensation also you can put. Condensation already you know, no? Condenser means water which cool the liquid and convert the gas into liquid, right? So here there is a mixture of acetone and water, and here what we do? We heat it. Okay, so we heat here. So at what temperature we heat? The temperature should be greater than 56 but less than 100. That should be greater than 56 and less than 100. So approximately we take 70 degrees. Okay. So now we heat and we maintain the temperature here approximately 70 degrees Celsius. What is the temperature? 70 degrees Celsius. Okay. So 70 degrees Celsius is what? Greater than 56. It's what? Greater than 56. Acetone boiling point is what? 56 degrees Celsius means what? It boils. Boils means what? Boiling point means what? The temperature at which the liquid convert into gas. So now the temperature is what? 70 degrees Celsius. So what happens? This acetone which is present inside, okay, that will be converting into the gas, right? So now this acetone, only acetone will be converting into the gas, and this gases rises up through this delivery tube. Okay, it rises up and it will be moving through this delivery tube here. Okay, so like this it will be moving. Okay, what it is? It's a gas. It's moving. Okay, acetone in terms of vapor. In terms of vapor, vapor means what? A gas. So in terms of vapor, it's going like this, right? So when it's going here, then we arranged one condenser here. Condenser means what? Through which we can pass the cool water so that this get cooled, this vapor get cooled. When this vapor get cooled, now it get condenses and it forms a liquid. Now what it forms? A liquid, and the liquid is collected here. So like this acetone is collected and here water is left here. Okay, so this method is called as a condensation. What is called? Distillation. What is called? Distillation. So distillation is nothing but a we take the mixture of two liquids in which the two liquids boiling point difference should be greater than 30 degrees. Remember here, greater than 30 degrees. Then we maintain, means we heat that liquid, and there we maintain the temperature between the two boiling points. So here acetone is 56 and water is 100. Between these two approximately 70 degrees. So we are at this temperature, then acetone, okay, boiling point is only 56 but we are heating up to 70. So what happens? It get evaporated. So this boils and get evaporated. Evaporated will come here and we condense it and we collect the this acetone. So in this way acetone get separated and water left here. So this is called what is called distillation. Okay, This is a distillation, student. Understood the distillation? Any doubt for distillation? Okay. So, fractional distillation is also same. So, difference between the distillation and fractional distillation is that distillation is used for the liquids whose temperature, okay, difference between their boiling points is greater than 30. If the temperature difference between the boiling points is less than 30, less than 25, then we can use fractional distillation. What we can use? Fractional distillation we can use here. So, here see a fractional distillation. Fractional distillation is a process which involves distillation and collect of fractions of different liquids, liquids boiling at a different temperature. So, here also same, okay, but here the only thing is that temperature difference, boiling points difference should be less than 25 to 30 degrees, okay. So, now you see here. So, here you can see this is the diagram for the fractional distillation. So, here they have taken the two liquids. So, this is a mixture of two liquids, and here remember that the temperature difference in the boiling point should be less than 25 or 30 degrees. So, here what we can take? We can take alcohol. We can take alcohol and water. Water is 100 degrees and alcohol is I think approximately 76, approximately 70, ethyl alcohol is 78. How much students? 78, okay. So, in such cases we use this method, okay. So, in this method see here we are taking the two liquids, okay. What are those two liquids? One is alcohol and water, okay. So, we take the mixture of water, and water boiling point is how much? 100 degrees Celsius, and the second one we take the ethyl alcohol. What do we take? Ethyl alcohol, and ethyl alcohol boiling point is 78, approximately 78 degrees Celsius. So, what is the difference between these two? The difference between is only 22, approximately 22 degrees Celsius is the difference, and which is less than 30 degrees, which is what? Less than 30 degrees. So, in case where the temperature is less than 30 degrees, temperature difference between two liquids is less than 30 degrees, in such case we use the fractional distillation method. Is this clear? So, distillation, fractional distillation both are same, remember that. So, distillation is used to separate the two liquids if the temperature difference between their boiling points is greater than 30 degrees, and fractional distillation we use if it is less than 30 degrees, right. So, here what we use the two liquids, we use water and alcohol. Water is 100 degrees, alcohol is 78 degrees, the temperature difference is only 22. So, here the procedure remains same. So, as I told you, just now I told you, what is the procedure I told? Okay. So, in the same procedure, here also there is the same procedure, here also we are taking the same mixture only we are taking, that is water and acetone, and here we are heating, and one of the liquid is converting into the vapor, and this vapor is going away, and we are getting condensed here, okay. So, that liquid we are separating. The same method we can do here also. Okay. So, see here the same, there is a mixture we are taking, right. There is a mixture of, for example, water and alcohol, and this is the round bottom flask or distillation flask we can say, and this is a cork, and here one extra thing is that here fractionating column. So, this is very important here, fractionating column. So, this is a fractionating column present here, right, and here one thermometer is maintained here. This is a thermometer, see here thermometer can see to measure the temperature, and now on heating. So, out of two liquids, so here the alcohol temperature is what? 78, water is what? 100 degrees. So, what we need to maintain the temperature here? The between these two means less than 100, greater than 78. So, approximately we take 85 or 90 degrees Celsius. So, here we can maintain the temperature of 90 degrees Celsius. Okay. At this 90 degrees Celsius or this 96 degrees Celsius is greater than 78, is greater than 78. So, now what happens? This alcohol evaporates, right. So, alcohol get evaporated. So, this evaporated alcohol goes through this fractionating column, and it goes through this delivery tube. Okay, this is a delivery tube. Now, this delivery tube is mixed with what? Water condenser. Condenser means water which cools the vapor and converts the vapor into the liquid. So, condensation means what? The process of converting the vapor into liquid is called a condenser. So, here what happens? Now, these alcohol vapors when entering here, they get condensed. After condensing, now here they convert into liquids. This liquid is collected here. So, in this way, alcohol is separated and water will be left over here. That's all. So, that is the process of separating the two liquids by using fractionation and distillation. Clear to you? Any doubt in this one? Right? So, chalo see. So, this is about the fractional distillation. So, here liquid differ by 30 degrees or more, we use a normal distillation. If the difference is less, a fractionating column, then it is used the fractional distillation. So, fractional distillation is used if the temperature difference is less than 30 degrees. Okay. So, where we can use this one? This we can use to separate the alcohol and acetone. Alcohol and water, or acetone and alcohol, because here water boiling point is 100, alcohol is 76. So, difference is what? Only 24 degrees. Similarly, if you take the alcohol and acetone, 56, 76. So, temperature again 20, which is less than 30 degrees Celsius. So, where the difference between the two liquids is less than 30 degrees in their boiling points, there we can use a fractional distillation. Chalo, once again see a methods of how can we separate. So, by using separating funnel, where we use a separating funnel for immiscible liquids. Immiscible means what? Which do not mix with each other, like water and oil, carbon disulfide and water, chloroform and water, all these cases we use this one, right. So, now see distillation when the liquids miscible and have difference 30 degrees or more. This is for distillation. And fractional distillation, the two liquid dissolve in one another and difference in their boiling points is less than 30 degrees. That's all, friends. So, with this we completed this chapter. Okay. So, with this we completed this chapter, and now if you have a material, once you open the page number, we solve the questions. Page number 87. So, open the page number 87. So, here are the questions. Okay, here the questions are there. Practice sheet. See here two practice sheet. Come, let's explore. Concept based question. The first one. The best method of separation of a solid liquid mixture. Solid liquid. Okay, which is the best method? Sedimentation, filtration, decantation, crystallization. So, filtration is best method, right? Because as I told you in the last class that if sand and water are mixed with each other, then what happens? The sand will be settled down, water will be left over at the top. We can separate. But for example, if you think that sand consists of some dust particles, then what happens? We cannot separate them. So, by using the filtration. Next, sedimentation is what? Soluble of solid material which get dissolved? No. Insoluble solid material, yes, insoluble solid material which settles down is in the sedimentation process, like sand and water. So, sand will not be dissolved with water, it will be settled down, right. Third question, the clear liquid above the sediment when a suspension is allowed is called a supernatant liquid. So, the option is 3. Next, the clear liquid obtained from mixture of solid and liquid by the process of filtration is called filtrate. What is this? Filtrate. So, filtrate is the right answer. This is a filtrate is the right answer, right. Next one, in common salt solution. Common salt means what? Salt and water. Normally salt is salt and water. If it mixed, how can we separate? By evaporation. In the last class I explained you that. So, if seawater, from the seawater we can take the salt. How we can say we collect the seawater in like reservoirs and then we left over for evaporation. So, due to sunlight the water get evaporated, only salt will be left. So, here salt will be separated by using the evaporation. Now, sixth question, you see the process of changing a liquid into gaseous state. Process of changing the liquid into gaseous state, below its melting point is called, boiling point is called what? Evaporation. At the boiling point is called vaporization. See here, if water, this also explained you, water if you boil at 100 degrees Celsius, on a stove, okay, then what happens? Water boils. So that is called vaporization. Just if you throw the water outside and see after some time whether the water will be there, no, water will get evaporated. So we are not boiling. So below that temperature only the water get evaporated. Okay. So the water if evaporates below its boiling point is called as evaporation, and at a particular temperature, okay, if it converts into gaseous state, that is called as a vaporization, right. Next, iodine in chloroform, they are separated by, that is distillation, just now we discussed. Which of the following separation techniques is used to separate the liquid component of a solid liquid mixture? Solid liquid mixture. Sublimation, no. And diffusion, no. Distillation, yes. So distillation method we can use to separate the solid and liquid. Next, blood and other biological samples are separated by centrifugal force. As I discussed, centrifuges. Centrifuges we can use to separate the samples of blood components, and even washing machine also I gave an example. Washing machine after washing the clothes, so the clothes get dried by rotating the drum. Okay. So during what happens? During the centrifugal force develops, and this centrifugal force push the water molecules away from the clothes, right. So clothes get dried. So these are the questions, and of course we can do the exercise 1 also. The process in which a suspension of a insoluble fine particles suspended in the liquid are allowed to stand leaving the clear liquid is called sedimentation. This already we discussed by giving an example like water and chalk powder. Okay. So if you take the water and take the chalk powder and mix it, stir it. When you stir it, it looks like that will be dissolving. And after that what you do? You place this solution without disturbing it for half an hour or 1 hour. So what you will observe? All the chalk particles okay, will be settled down, and then clear water is formed above it. So we can separate that clear water. This process is called sedimentation. So option is 3. Next question. Water containing sand can be separated by the method of sedimentation and decantation. The principle behind the sedimentation and decantation technique is one of the component is heavier and then the liquid and is insoluble. Correct only, that is. So first option is the right answer. Barium sulfate and water can be separated by filtration. Yes. In which of the following is left a residue? So water can be separated through the filtration. Barium sulfate will be, as it is a residue, so it will be separated out. So option is a barium sulfate. Second option. Which of the following are solid liquid mixture? Water and salt? Yes. Iodine and methyl alcohol? Iodine actually it will be exist in 2 states, liquid state as well as solid state. So you can give here both 1 and 2 is the answer, students. So the 4th option is the right answer. Then go to the 5th question. Page number 89. Iodine in methyl alcohol can be separated by, just now we discussed distillation. Next, the 6th question. The process of separation of insoluble solid constituent of a mixture from the liquid constituent by passing through it some porous material, that is called filtration. Example yesterday I gave, like your mom prepared the tea. After preparing the tea powder can be separated by the filtration. Yes. So the answer is filtration. 7th one. Silver chloride particles in water can be separated by same filtration. What is the principle of centrifugation? Denser particles stay at the top? No. Lighter particles forced to bottom? No. Denser particles forced to the bottom and lighter particles stay at the top. This is the right answer. So 8th one is 3. 9th question is, state the principle involved in separation liquid by separating funnel. Separating funnel, just now we discussed. Separating funnel for what? 2 immiscible liquids and depending their densities. No? So what is the right answer? Immiscible liquid separate depending on their masses? No. Immiscible liquid separated depends on their volume? No. Immiscible liquids are separated depends on their color? No. Immiscible liquids are separated depends on their density is the right answer. So 4th option. Formula of silver chloride, of course it does not belong to this chapter, but already long back we discussed how to write the formulas. So that is silver chloride formula is AgCl. Formula of barium sulfate, BaSO4. Chalk is a common name of limestone, that's calcium carbonate, right? And numerical type, boiling point of ethyl alcohol, just now we told you that 78 degrees Celsius, right? Chalo. So students, with this we completed this chapter, and this chapter is the last chapter of your IIT Foundation. So here, hope your total IIT Foundation chemistry part is completed, and if you didn't receive any one of the topics or any one of this one, so just intimate to us so that we try to send it once again. Okay. So, and I hope you are receiving the chapter wise questions on question paper also for practice. So, you continue with this one. If you have any doubt, we clear, okay, class wise. Okay. So, take care. Bye.